Hey Valley Middle, welcome back to another math lesson. Tonight we're going to look at sample space and how you use that to find the probability of an event. Let's start off with a smelly trivia question. What is a stinking toe and it's not that thing on Uncle Fred's foot? Well, officially tonight we have a double targetto. 9.2a, I can find the sample space for an event, and 9.2b, I can use that sample space to find the probability of an event. Let's do this thing. Casey likes cool kicks and sweet socks. He has a red and black pair of Jordans. He has 3 pair of Nike Elites, red, white, and blue. He's going to wear one combination every day before repeating any combinations. All right, identify the sample space. What that's asking for is how many different possible combinations are there? And then what is the probability that he will wear the red shoes and the red socks on day 1? All right, so what I used a tree diagram. I got his black shoes and I got his red shoes, and then I got his red socks, white socks, and blue socks because he could wear black shoes and red socks, black shoes and white socks, black shoes and blue socks, correct? And then I did the same thing for the red shoes. Then I took and made a little list for the sample space, black shoes, red socks, and used initials to abbreviate it. So I had a total of 1, 2, 3, 4, 5, 6 possible combinations. And only one of them was red shoes and red socks. Therefore, the answer to my sample space question is right here. Here are the 6 possible combinations, and the probability, the answer to that question is down here. The probability of red and red, well, there's 1 chance out of 6 possible outcomes or combinations. 1 in 6. That's what we're going to be working with tonight, sample space, and using that to determine probability. So, guess what the words of the day are? Sample space, the set of all possible outcomes for an event. And then we got tree diagram. That's one organized way to find all the possible outcomes in the sample space. Let's just take a quick look here at the spinning die here. What's the probability of rolling a 1? Well, the sample space would be a 1, 2, 3, 4, 5, or 6. These are all the possible outcomes. And of course, there's only 1 chance of throwing a 1, so it's 1 in 6. What's the probability of rolling a 3 or 4, and what is the sample space? Well, again, here are all the possible combinations, and of course there's 2 possible outcomes that are favorable, so that's 2 and 6 as the probability. Of course, expressing that in lowest terms, that would be 1/3. So there are some different ways to organize sample space. A list is one way of doing it. A tree diagram is a great way, and so is a table and a chart. Let's try to see if we can apply what we've learned to some different problems. All right, so here's a spinner here. I spin the spinner to practice my multiples of 6. What is the probability of getting a product that is a multiple of 4? And what is the sample space? Well, this one's a pretty straightforward one. I know exactly how many different possibilities I'm going to have because it's a spinner. So I just used a list here. So I listed all the different products out, 6 times 1, 6 times 2, 6 times 3, and so on. Now I just have to go through and find out what my probability of getting a product with a multiple of that is a multiple of 4. Well, 12 is a multiple of 4. Whoa. 24 is a multiple of 4. And 36 is a multiple. Whoa. 36 is a multiple of 4. 48 is a multiple of 4. 60 is a multiple of 4, and so is 72. So my sample space includes all of these numbers, total of 12. Probability of the event, getting a multiple of 4, is actually, I did that wrong. Probability of getting a multiple of 4 is actually 6/12. 6 out of the 12. And, of course, that can be reduced down to 1/2. Sorry, I forgot to change that. So you take a quick look at the sample space. Those are all the different numbers that are listed. Those are all the different multiples. And then the total possible outcomes, you reduce it down. So you're just using that sample space, that list, to find your probability. All right, another great way to find or organize your information for a sample space is by using a table or a chart. This is often used with questions about flipping coins. So here's a classic. I flip 3 pennies in the air and let them fall. What is the sample space? They want to find out what the probability of all the coins landing tail side up or all heads. In this case here, we want the probability of all coins landing tail side up. But we first of all have to find the sample space. So this is a chart is really an organized list. So I started off with all heads. Heads, heads, heads. Then I could have heads, tails, heads, and heads, heads, tails. And I keep moving it around until I have all the different possible combinations. And I ended up with tails, tails, tails. And I even had an extra line down here because I wasn't sure how many different possible combinations there were going to be. I just started listing them. Well, I found out that there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possible things that could happen when I flip those coins and let them fall. So my possible outcomes are 8. The chances of getting all tails is 1. So the probability of getting all, actually, sorry, this is supposed to be all tails, is 1 in 8. That is in simplest form, so I don't have to reduce it anymore. Okay? Sample space, all of these things listed. So if I had to list that on the test, I'd just list HHH, HTH, or I'd put a little arrow going over just like I did. Here's my sample space. Here's my list of events. All right, and a problem with the tree diagram. McDonald's has 3 different Happy Meals: chicken nuggets, cheeseburger, and hamburger. You can order each meal with milk, juice, or soft drink. Your parents bring you home one of these meals for a younger brother or sister, I suppose. What is that sample space, and what is the probability of your parent bringing you or your brother home a meal with milk and a cheeseburger? So you have to figure out all the possible combinations. That's the sample space, all the possible combinations. So I listed out nuggets, hamburger, and cheeseburger, and then made a tree diagram. You could have it with milk, juice, or soft drink. You could have the hamburger with milk, juice, or soft drink, and the cheeseburger with milk, juice, or soft drink. Then for my sample space, I just abbreviated these so I had a nice neat list. Nuggets and milk, nuggets and juice, nuggets and soft drink. Okay? So you can see that I had a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see them here, groups of 3 easier. So I had a probability of 9 events, but only one of them included a cheeseburger and milk. Here's my cheeseburger and milk. So the probability of that event is 1 out of 9. I use my sample space to figure out how many different possible combinations I had and determine the probability. You with me? You ready to try one on your own? All right. Here's a problem about Mrs. Carruthers. Mrs. Carruthers has 2 coats, a North Face and a Columbia. She has 4 pairs of boots: black, brown, tan, and gray. She doesn't like to wear the same combination too often, so she wears all of the possible combinations before she repeats that sequence. Kind of like Casey and his socks. That's the kind of problem we're looking at here, socks and shoes. So identify the sample space, and on any given day, what is the probability that she will be wearing gray boots? Go ahead and take a few minutes and make this chart. This is the only one I'm going to ask you to do tonight. Go ahead. All right, let's see. Well, the sample space, I think a tree diagram works best for this one. So that's what I made here. Here's her North Face coat, and here's her Columbia, and I listed all the 4 different types of boots. So you can see I had a total of 8 different possibilities or combinations. Therefore, I know my denominator is going to be 8, but I have to figure out how many possible outcomes there were with gray boots, because that's what we wanted. What's the probability of her wearing gray boots? Well, she could wear the North Face with the gray, here it is NG, or she could wear the Columbia with the gray, the CG. So out of 8 combinations, there was a total of 2 with gray boots. So the probability of that will be 1 in 4 once I reduce that into simplest form. All right, now this next one, I have to give you one more problem, but I did the sample space for you. Because I wanted to do one about rolling 2 die, and this happens all the time. These are another popular combination. So I roll 2 standard die. What are the chances of rolling a sum of 7 or 11? So you either can have 7 or 11, but identify what the sample space is, and I've given it to you. You just have to figure out how many of them there are, and what is the probability of getting a 7 or 11. So once you pause it, leave the screen open so you can look at the different sample space, or count the number of the sample space items. Go. Alrighty. Well, I answered it in a different page. So There are a total of 36 different combinations, and I got that very easily by counting down 1, 2, 3, 4, 5, 6 by 6 going this way. So 6 different combinations. And we had that, 36 different combinations. And we had that in a previous lesson on probability. Then I went through and I circled all the 7s. Well, you could have 6 and 1, 2 and 5, 4 and 3, and then those, of course, repeat for the other die. And then there was only 2 11 combinations. You could have a 6 and a 5, or a 5 and a 6, depending upon the color. So I ended up with a total of 8 different possibilities out of 36, which reduced down to a probability of 2/9. All right, let me get you to the ticket for the show. We're going to work on a number of these types of problems tomorrow in class. Here's a quick one I made up. Find the sample space and the probability of this event. There are 3 kinds of ice cream: strawberry, chocolate, vanilla. There are 3 toppings: strawberry, chocolate, and pineapple. What is the sample space? In other words, how many different combinations with 1 topping and 1 kind of ice cream? And what is the probability of a random scoop of ice cream with 1 topping would be vanilla and a fruit topping? All right, so 1 scoop of ice cream and having a fruit topping on. Figure out what that sample space is, and then what the probability of it is. Okay, thank you, and let's get to the trivia question. Our just for fun question is, what is a stinking toe? It actually refers to a large seed pod of the West Indian locust. Kind of cool, huh? All right. Thank you very much for listening. See you tomorrow in school. Bye.